Today we're going to wrap up the first part of Unit 2, and that's what Lesson 6 here, talking about using equations to solve problems. We're still going to be using tables, we'll be using equations, we're going to be using both constants of proportionality in our proportional relationship and looking at how that changes to work best with what we're trying to find. We're going to start with a number talk, which means no calculating. We're not going to solve the actual problem. We're just going to use what we know about numbers to answer the question. And it says we're going to order the quotients. Remember, the quotient is the answer to a division problem of these expressions from least to greatest. So we're thinking of the answer to these 4 division problems. The first choice is going to be the smallest answer, the smallest quotient, and the last choice will be the largest. Now, as I look at these 4 problems, these 4 expressions, I see that they all have the same dividend except for this last one. It's the same digits, but they're in a different place, so they have a different value. What I want to try to do is make that the same. So I want to turn 426 into 42.6. That means this number is going to become 1/10 the size. It's going to get a place value smaller. In division, if I change this quantity to 1/10 the size, and I also change the divisor to 1/10 the size, it will be equivalent. You can think about that this way. If I were to take 40 divided by 20, the answer is 2. Now if I write that 1/10 the size, so I get 10 times smaller, 40 would become 4, and 20 would become 2, this is going to have the same quotient. So let's do that with the problem we're working with. 42.6 divided by 7 will have the same quotient as what we were first given originally. Now let's think about division. We have the same dividend in each expression. So we have the same quantity, the same amount, which is 42.6. Now what we're going to do is divide it into certain sized groups. The bigger the group is that I take from 42.6, the fewer number of groups I'll be able to take. If I take a very small group size out, I should be able to take a lot of those groups from 42.6. So this should have a very high quotient, whereas a group that's 70, that's a group bigger than what we actually have, is going to have a very small number of groups. So to order those, I am looking here at the divisor. The largest divisor is 70, so that's going to have the fewest number of groups. 7 is the next largest, 7/10, and then 7/100. So a large divisor will give me a very small answer, small quotient. A small divisor will give me many, many groups and a large quotient. All right, moving into some of our problem solving with proportional relationships. The problem says a performer expects to sell 5,000 tickets for an upcoming concert. They want to make a total of $311,000 in sales from these tickets. Make sure you are showing work. So assuming that all tickets have the same price, that means we have a constant ticket price. So we're going to have a proportional relationship. What is the price of one ticket? One ticket represents a unit rate, which is going to tell us the constant of proportionality. When we find the price per ticket, that will be our constant of proportionality. So we also have a few other things to find. We want to find how much will be made if 7,000 tickets sell, 10,000, 120,000 tickets, or X tickets. So that's all going to need to be part of our calculation. And then we're going to work backwards. So if they make $379,420, how many tickets have they sold? And we're going to do the same for $5 million. Now, we could most certainly make a table. We are going to be using equations a lot in solving what we're trying to do here today. So by finding that unit rate, the price for one ticket, that will tell me how to write an equation for this. Remember, I'm trying to fit the format y equals k times x. I need to find k, I need to find that constant of proportionality. So knowing that the performer expects to sell $311,000 in tickets, and that's by selling 5,000 tickets, if I set up a ratio with that, $311,000 for 5,000 tickets, by reducing this, by simplifying it, or just by dividing it, I will get my unit rate. And that unit rate is $62.20 per ticket. That means that my equation now is y equals $62.20 per ticket. And I could change those variables. So I could use something to represent what's in the problem. I could say this is T for tickets. I'm going to multiply that by my constant of proportionality, and that will tell me the earnings or the profits. Now let's look at the individual questions. So how much will they make if they sell 7,000 tickets? All I have to do with my equation now is input 7,000 into the ticket number, multiply each of those 7,000 tickets by the price per ticket, the constant of proportionality, and I'll have the total income here. So that would be for 7,000 tickets, $435,400. Then I'm going to do the same for 10,000. Now again, this can all be organized in a table, and there is nothing wrong with doing it that way. But using my equation, if I put in 10,000 tickets into that quantity, 10,000 times $62.20 is just going to move some place values, multiplying by 10,000, and that would add up to $622,000. If I do the same for 120,000 tickets, they will earn $7,464,000. And then, of course, for X tickets, putting in X tickets here for my variable, putting in a variable for a variable, I just rewrite this expression. So I would write 6220 times X. And remember, I don't need a multiplication sign. I'm just going to put them side by side to show multiplication. So now the question asks, if they make $379,420, how many tickets have they sold? Now, what I'm really doing is reversing this equation. So I'm going to put in the amount earned here for Y. To find how many tickets they sold, I need to calculate for T. So to do that, I could write a new equation where I'm using the reciprocal of $62.20, or I could just use division. It's going to get me the same result. So if I take the earnings, divide it by the cost per ticket, it will tell me how many tickets were sold. And that quantity is 6,100. Remember, we're not talking dollars anymore. This is tickets. And if we do the same for $5 million in earnings, how many tickets will they have to sell to make $5 million? I take 5 million, divide by the cost per ticket, and that will tell me how many tickets would need to be sold. That is 80,385.85. I'm sorry, 852. Now, hopefully that sends up some red flags for you, because it is impossible to sell this decimal amount, 852 thousandths of a ticket. You cannot sell a part of a ticket. So if the person would like to make $5 million and we just get rid of this, ask yourself, will they make $5 million? No, they actually won't. They will be short of their goal. So what logically they would have to do is increase this to a full extra ticket being purchased. They'll make just over $5 million, but our best answer to this would be that they need to sell 80,386 tickets, and that would be a logical amount. Now let's look at the back of your handout. So we're talking about recycling, and to organize this, so let's read the situation first. It says aluminum cans can be recycled instead of being thrown in the garbage. The weight of 10 aluminum cans is 16 hundredths of a kilometer. I'm sorry, of a kilogram. The aluminum in 10 cans that's recycled has a value of 14 cents. Show how you get your answers, make a table, and explain your reasoning. So we could make a table that compares the three things that we're told here. We're told that we have a number of cans, in this case 10. We're told that the 10 cans have a certain weight, and we're told their value when you recycle them. So what I could do is make a big table with 3 columns and compare that way. But I think it's going to be a little more confusing if we do that, instead of just making smaller tables that are only comparing 2 quantities. So let's look at the first question and see what we need to compare. If a family threw away 2.4 kilograms, that's weight, in a month, how many cans did they throw away? So here in that table, we need to compare weight. We need to compare cans to weight. Remember, the ratio we were given originally is that 10 cans has a weight of 16 hundredths of a kilogram. All right, now what we would want to know is how many cans are in a kilogram. Okay, to solve this problem, we would want to know how to compare the weight to the number of cans. So, weight and cans. We were told that 10 cans weighs 16 hundredths of a kilogram. Okay, to solve that, let's create a small table. So we're going to compare the cans, which we'll call C, to the weight, which is represented in kilograms. We're told originally that 10 cans has a weight of 16/100ths of a kilogram. Now, what we would also want to know is what 1 can weighs, our unit rate. So, if we take the ratio that we're given, find that constant of proportionality, that thing we're multiplying 10 by to get 16/100ths, we can reverse that and divide. Let's take this ratio of weight to cans, 16/100ths divided by 10 to find our unit rate, which would be 0.016, 16 thousandths. That's our unit rate. This is our constant of proportionality. 1 can has this weight. So now to answer the question being asked, there's a weight of 2.4 kilograms. We need to figure out how many cans that is. So we could try to find the reciprocal of this, which could be a little extra effort, or because to multiply the cans times our constant of proportionality, we could reverse that and use division. 2.4 being our total weight divided by our constant of proportionality now will tell us the number of cans, and that would be 150 cans. Okay, next it wants to know what's the recycled value of those cans. So we have a weight and we have a number of cans. What we could do next is make a table comparing weight to value, and value they describe down in another question as R. All right, but I'm just going to put a little dollar sign here next to it so we remember what we're talking about. So let's go back to our original situation here on top. If our weight is 16/100ths kilograms and that's valued at 14 cents, let's add that into our table. By dividing 14/100ths, 14 cents, by 16/100ths, we will find what 1 kilogram has a value of. So dividing that will give me and I'm going to write it in red because that's my constant of proportionality. That 1 kilogram of cans has a value of about 88 cents. So let's look back at the question. What was the recycled value of these cans? So we had 150 cans weighing 2.4 kilograms. Let's add that to our table. I've got some room above here, so I'm going to put 2.4, because remember this column here on the left is representing weight. Now I'm going to multiply it by the constant of proportionality, and that should tell me the value of that 2.4 kilograms. So I'll multiply by that, and 2.4 kilograms has a value, write it in blue again, of $2.10. Now we're going to go to the equations again. So first it asks to write an equation to represent the number of cans C given their weight W. All right, our equation is we want to find the number of cans C using the weight W, and I just need to know the constant of proportionality here. So that's actually going to be the opposite of what this table is showing me. Here we went from cans, number of cans, to getting the weight. That was what this constant of proportionality showed us. Now we're working the opposite way. We want to take a weight, multiply it by something, to get the number of cans. So in a sense, it's what happened here. What we need to do is we need to do some division to find the constant of proportionality. It's not as easy to see what the reciprocal is of this constant of proportionality. So instead of taking 16 hundredths divided by 10 to get this, we're going to reverse it and do 10 divided by 16 hundredths, and that will tell us how to go in this direction. We would be multiplying by 62.5. That's going to be the constant of proportionality in my equation. And I would test it. I would take a weight from this column, let's say 2.4, multiply it by 62.5 and make sure I get the correct number of cans, 150. For the next one, we're going to make an equation to represent the recycled value R of C cans. The recycled value R of C cans. So here, we don't have a table to represent that. We could make a quick table. C cans. We know that 10 cans have a value of 14 cents from our original information at the top of the problem. Now, we want to find, let's start this equation so we start writing it correctly. We want to find the value by inputting the number of cans with the constant of proportionality. So, if I input the number of cans, what do I multiply by to get that value? Let's divide. Let's find the constant of proportionality here, or what is the value of 1 can. Now I've run out of space on my page, but I'm going to take 14 cents divided by 10 to get that constant of proportionality. That's just going to move my decimal 1 spot here, get 1/10 the size, and 1 can is going to be worth 0.014 cents. There is my constant of proportionality, 0.014. This is the value of 1 can, and I would multiply that by the number of cans to get the total value. All right, and then lastly, we have to write one more equation. This is going to be from our table here, comparing weight to value. So I again want to find the value R. Here I'm going to be multiplying the weight times my constant of proportionality. So using the table to turn a weight into a value, I need to go to my unit rate and what I was multiplying by. My unit rate said that 1 kilogram of cans is worth $0.875, so just under 88 cents. That's my constant of proportionality, 0.875. And that would give me a value for a particular weight. All right. I know this was a little bit longer lesson video today, and what I want to do is give you the opportunity to look at activity 6.4 granola in your handout. The questions are a little bit easier than what we just did. You're certainly welcome to make a table for those granola questions, and that's here. You're certainly welcome to make a table for that or create an equation. But remember, you always want to start by finding that unit rate and that constant of proportionality that you can use to answer your question. If you have any questions, please talk to Mr. Johnson, or I'll be on Zoom to help you out so we can clear up anything that you're wondering on the granola activity before you start your practice problems. Have a great day.